Today we're going to begin looking at how to graph a car, in this case a car, an object that is traveling at a constant speed. So we're going to talk about this scenario here. So to begin, let's consider a car moving with a constant or rightward velocity. And let's say a positive or plus 10 meters per second. So 10 meters per second, it's moving at a constant velocity here. If the position time data for a car were graphed, then the resulting graph would look like this graph right here. Notice that the motion is constant. It's a positive velocity, results in a line of constant and positive slope when graphed in a position time graph. So here's my position on my y-axis in meters and my time on my x-axis measured in seconds. So notice the straight line identifies a constant positive velocity here. But let's consider a car that's moving with a rightward, right, a positive changing velocity. That is a car that's moving rightward but is speeding up or is accelerating, right? Remember in class we started identifying acceleration means, well, it's changing its speed. Now positive, in this case we're going to be talking about it is speeding up as it's moving to the right. So here my scenario, the position is traveling to the right, it's speeding up, so it's covering a greater distance or a greater position in its same unit of time per second. So you'll notice it's covering more area in each unit of time. So if the position time data for such a car were graphed, the result would look like this one here to the right, and it would be curved upwards. Note that the motion described as a changing positive velocity results in a line of changing and positive slope when plotted as a position time graph. So the position time graphs for the two different types of motion we looked at, for constant velocity and changing velocity, are depicted as follows. For a position time graph constant velocity, it's going to be a straight line angled upward, and for a changing velocity or accelerating, in this case it's speeding up, it's going to be curved upwards as the second graph here shows. So here we can start looking at what the slope is referring to in terms of the general velocity, or in this case we can also use the word speed for this. And you can read this on your own. Well, I'm simply just referencing the screencast from the physics classroom activity that you should have been able to do on your own. But I want you to see this. We made a rule in class that the steeper the slope, the faster the speed. The gentler the slope, the slower the speed. So you'll notice that on the picture here on the left, this graph here, it's a gentler slope than the picture or the graph on the right, which is a steeper slope. So we can actually come forth and deduce that the picture on the right, the graph on the right, is showing the motion of a car or an object that's traveling faster than the graph here, or the object that's moving in the graph to the left. Very important here. The slope for a position time graph is the speed. In this case we're going to be using velocity and speed synonymously, or kind of as the same thing for now. We'll continue to differentiate speed and velocity as we've already begun to in class. So let's put this concept into motion here. You'll observe there's two cars moving here. And this is an animation that's found on the physics classroom, but it allows you to look at two different objects moving at two different velocities, kind of at the same time, simultaneously. So it's called the passing lane. So the blue car is traveling at a constant speed, or in this case constant velocity, to the right, and the red car is going to surpass it. And I want you to see how the graphs work. Constant speed, constant velocity of the blue car, it's a gentle slope, it's traveling slower. But you'll notice 4 seconds in, the red car comes into play and it passes it as it's traveling to the right. And you'll notice it's a steeper slope, which shows us or tells us that the red car is traveling at a greater speed, and therefore it's going to bypass or surpass the blue car that's traveling at a slower speed. And we can also see this in terms of the slope differences as well. So in summary, if you can take away that you understand the general concept of a position time graph, that a straight line implies a constant velocity, or in this case we'll use constant speed, and that a curved line, in this case it's a changing line, it's not straight, so therefore its velocity, or in this case its speed, must be changing too. You can also see that the slope is getting steeper, so therefore we've identified that slope of a position time graph is the speed. Therefore, if the slope is increasing, the speed is increasing. So if we had had a graph where its slope was actually started off steeper and then gently began curving downward, that car would be slowing down. But for now, straight lines are constant velocities, curved lines are changing velocities. There you have it.